Hello everyone, this is Shraddha Bhurre from IAPS TV Bandar, and today we'll discuss the consequences of floating point representation. So this floating point is a method of representing an approximation of a real number. A real number can have many digits after decimal, so we have to truncate that digits. So whenever truncation is done, it leads to error. So some of these errors are discussed. So in arithmetic operations, it follows two laws, associative law and distributive law. So associative law say that a plus b minus c equals to a minus c plus b. So this law isn't verified in the floating point representation. We can see that by assume the nearly equal values for a, b and c. Now we compute the value for a plus b, that is for LHS. We'll have 0.5720 10 raised to power e1 for a plus b. Now adding the value of c in this, we'll have 0.7600 into 10 raised to power minus 1. Now we'll compute for RHS, that is for a minus c plus b. So our a minus c will be 0.2100 into 10 raised to power minus 1. Now adding value of b in a minus c will have 0.7656 into 10 raised to power minus 1. So here we can see that our LHS is 0.7600 into 10 raised to power minus 1 and our RHS is 0.7656 10 raised to power minus 1. So our LHS is not equal to RHS, that is associative law in floating point isn't verified. So now we'll test the distributive law. According to distributive law, a into b minus c is equal to ab minus cc. Again, we assume the nearly equal value for a, b and c, that is for a is 0.5555 into 10 raised to power 1, b is 0.4545 into 10 raised to power 1 and c is 0.4535 into 10 raised to power 1. Now first we'll compute LHS, that is a into b minus c. So our b minus c will be 0.1000 into 10 raised to power minus 1. Now multiply the value of a into this. So we'll have 0.5550 into 10 raised to power minus 1. Now again, we'll compute the RHS, that is AB minus AC. So our AB will be 0.2524 into 10 raised to power 2 and AC will be 0.2519 into 10 raised to power 2. So our RHS will become 0.5000 into 10 raised to power 1. So here we can see that our LHS, that is 0.5550 into 10 raised to power minus 1 and RHS 0.5000 into 10 raised to power minus 1 is not equal. So our distributive law isn't verified. So while solving quadratic equation, that is x square plus 2x minus 2. So we know that the root of this quadratic will be minus b plus minus under root b square minus 4ac upon 2a. So our b here is 2, a is 1 and c is minus 2. So by substituting this value in this formula, our root obtained will be minus 1 plus minus under root 3. So when represented in floating point representation, this root will become, that is minus 1 plus root 3 will 0.7320 and minus 1 minus root 3 will 0.2732 10 raised to power 1. When now substituting the value of first root, that is 0.7320 in our quadratic equation, x square plus 2x minus 2, and computing this first, our answer will be minus 1,000 10 raised to power minus 2. And when we will compute the 2x minus 2 first, our answer will be minus 0.2000 into 10 raised to power minus 3. So in this way we get different values for the same root. So this is the consequences of floating point representation, and thank you for watching video. Have a nice day.